Okay, welcome to the session about the lessons that we have learned after building Kubernetes operator for Java application server. I'm Maciej Gruszka. I work as a senior director for product management and Oracle. I work with a Java enterprise software already for many years. I joined Oracle as a result of the acquisition of BA Systems. So I joined BA in 1999. So during that session, I would like you to understand what we have done with one of our application server in Oracle to make it running on Kubernetes. What kind of software we have developed, what kind of practices we have implemented, what kind of lessons we have learned after building operator. Why this matters, why really companies, especially that are taking care for enterprise customers, should start building operators for their old traditional software. And it's the trend of moving applications to Kubernetes is obvious. Kubernetes is probably the most popular and the most common platform in architecture design nowadays. And customers do hope to achieve many benefits from cloud-native architectures and containerization by adopting Kubernetes, regardless of the cloud vendors or even on-premise environment. They do look into Kubernetes as a way to go. The vendors of enterprise software, like Oracle is, supposed to make this transition to Kubernetes easier with their enterprise software. And the pattern of operator, we believe, is a common way to provide a specialized application operational behavior. So operator seems to be for us like a way to implement the best practices in all lifecycle operations, like how to patch, how to start, how to roll, how to scale, how to perform the most common operation. Why? Because very often I would say big enterprise software is having embedded state in their infrastructure. So they are not like a stateless set of instances that you simply can replicate multiple times in your environment and you're achieving functionality. Instances do carry state. So you need to do some lifecycle operation in particular order. We believe it really matters that vendors like for example, Oracle or other vendors for enterprise software are supposed to build operators. So in today's presentation, I would like to talk about what we have built. I'd like to present you really the operator that we have created, what kind of development choices we had, what kind of client libraries we selected from. Our operator, like an operator pattern, is like a controller that sits on top of customer resource definition and tries to match the state of customer resource definition into the actual state of Kubernetes resources like pods and services. So I explain our way of interacting with custom resource definition. I would like to talk a little bit about, what we're doing whenever the operator is running for a long time, what kind of issues we see, and how frequently we try to restart it. We do support many flavors of and versions of Kubernetes. So what about versioning of Kubernetes or versioning of custom resources may bring you as a issue? And at the end, I would like to answer for some basic questions. Basic question: would we do the same if we needed to write it again from scratch? We debated internally in our development team. Because we started with our operators journey like 4 or 5 years ago. And of course, it was a little bit hit and try approach at the beginning. So there was and our operator platforms and operators that we create for our enterprise software evolved over years, and new versions or new product that we deliver, for which we deliver operators for Kubernetes, probably differ a lot from the operators we created at the beginning. And so we started to debate, would we like to recreate the operator? And I would like to answer that question also as a lesson that we have learned. So I work in an app server team. Or for Oracle App Server is a WebLogic server. As I said, I joined as a result of the acquisition. So historically, we had many app servers. Right now, we are making a WebLogic single app server for Java. Our team also develops Coherence, that is a data grid, data caching product. We also develop microservice framework for Java apps. So reactive microservices you can write with an open source framework called Helidon. We recently also created a container management platform product called Verrazano, again, kept as an open source product that allow customers to manage containers in Kubernetes and manage lifecycle of complex containerized applications and plug them quickly into the observability, common security. I'm not gonna go into that. These products, all of them, except of Helidon, require to have a different type of operators. So I try to generalize my presentation today, not to talk about only one operator that we have developed, but we have operator for WebLogic, we have an operator for Coherence, and we have an operator for Verrazano as well, and try to share with you some best practices and some lessons we learned after building those platforms. We try to make with an operator an ability to move a traditional software, but in majority cases, our customers are running in VMs, and make them running in Kubernetes. Okay, so let's go into that's like a background and description. Let's go into details, how we design, how we build our operator, how we design and build for Java application server, and what we believe this is like a good best practice session for those companies who are looking how to build and design operator for stateful components that they may potentially would like to attract their customers to move to the Kubernetes. So first thing that we have designed is like a custom resource. Custom resource definition is like a construct in Kubernetes that allow you to define and register at the API server. So we created for our app server a definition how about information of this runtime status that we would like to keep about our app server. Also, all configurational information of how app server is configured, we decided to move to the custom resource definition. And we use custom resource definition to declare or specify the desired state of the resource in a runtime. And this is the role of operator, is to watch and look into the operator, onto the custom resource as a controller, and try to reflect the state described in this custom resource object into the services that are created in the Kubernetes. So this is the role of operator that we design, is to match a state described in this custom resource object into the state of pods, services, and other Kubernetes resources that operator create. So why to build operator? Operator is an application-specific controller that extends Kubernetes to create, configure, and manage instances of complex applications. App server, we believe, and the entire configuration is quite complex application. It's not like something that you may represent as a single pod. Of course, a single instance you may represent as a single pod, but usually customers create a complex configurations with multiple clusters, with multiple specialized instances, some responsible for messaging, some responsible for transaction manager, some for database connectivity. And whenever you would like to match and move that configuration to Kubernetes, you cannot just create like a single pod with an app server. Operator is responsible to create such kind of complex structure of different pods representing a different functionality and run them in Kubernetes. So some of other things that operator does is simplifies management on operation on the domain, on the web, on the application server itself. We also create RBAC roles to manage Kubernetes resources on behalf of the app server. So we create all necessary security roles. We also automate for users a lifecycle operation. So starting, stopping, patching, updating, scaling up, scaling down. Whenever user tries to perform such operation, they can reach the operator, and the operator exposes a REST API, a REST endpoint to perform some lifecycle operations. So we try to implement in the operator a best practices, how user manage app server environment. We are, of course, invoking the Kubernetes API to start, stop all necessary resources. Also, we are monitoring all and the operator, all resources that we have created. So generally, if operator created a pod with the instance of the server, and this pod is destroyed, then operator needs to register for the event and receive the event from Kubernetes and react on that event to recreate it. So ask Kubernetes to recreate. It happens, for example, when Kubernetes, you're draining down the node. You're draining down some managed node and we are removing pods and you're shutting down the node, then Kubernetes would shut down all pods associated with that node. And then operator gets this as an event and will ask Kubernetes to create it back, and the scheduling algorithm in Kubernetes will start it on another node. If we look into the architecture of operator, in our case, we developed our operator for app server for WebLogic as a Java application. So we distribute it as a Docker image with a Java application. We create and we keep it sources for operator on GitHub. We distribute Helm charts that creates deployments, RBAC roles, and all necessary resources in the Kubernetes whenever you install the operator. And the responsibility of operators are following. First, we look for or watching for add, modify, delete operation on custom resource type. So custom resource that describe our app server configuration. Whenever someone makes any modification or removal of that custom resource type, operator gets an event and we program how to react on that event. We also watching for changes to events for resources created by operator. So this is what I was saying. It means operator created some services, created some pods. If someone destroys it or Kubernetes makes a decision about killing or maybe some resource died, then operator needs to get notification, and we look for the notifications about these resources and we react on these notifications. We also serve some REST endpoints. So we have decided in our architecture to match such kind of controller functionality with some REST endpoints for typical lifecycle operations. So probably if we design today the operator, we might remove it for simplicity and clarity of the architecture. This is one of the features that if we look back in the history, we probably would design it differently, but our operator serves some REST endpoints. So we have some REST endpoints in the operator for typical lifecycle operation, but you may ask operator to perform on top of your configuration, like automatically start, automatically stop, patch, scale up, scale down. As few of these endpoints and REST endpoints are right now available. For the operator, customer resource is always the source of truth. So even though if we serve as a REST endpoint, for example, scaling up operation we perform, and customer or server calls scaling operation to the REST endpoint on the operator, then we, through the REST operator, modify domain first, domain customer resource first. So we modify customer resource in a proper location. We change the number of replicas. And then whenever we finish the modification, then we catch back the watch event that was fired by API server, and we react on this change on the resources. So we have always tried to keep the customer resource as a source of truth. This is a funny thing. After the operator for app servers, Oracle, we created several other operators, and many teams created many other operators. Even in our team, we created operator for coherence and for Verrazano later on. When we started the journey with operator, we selected Java as a language, mainly because we had engineering team that is good in enterprise Java, and for many, they have many years experience of building Java software. Over time, we hired a few other team members that are more familiar with the more modern languages. And for example, for Verrazano, we selected Go as a language for building operator. Do we see advantages or disadvantages? At this moment, we don't. It means probably if we design it once again, we would still debate what language we would like to do. So our recommendation or our best practice that we can share is use a language that your team is familiar with. Use a language where you have experienced developers for building operator. Really, programming language doesn't really matter so much. In our in programming Kubernetes operator in Java, generally there are a few choices of client libraries, Kubernetes client libraries that you can select. Originally, we started working with Fabricate. It's a Java client library is kept also on as an open source. However, very quickly we jump into the official Kubernetes client, and we continue our journey with building operator with the official Kubernetes client. What we see, there are a few benefits of doing that. Official Kubernetes client provides a timely releases of new clients for each Kubernetes release. So it's very convenient for us. And when we compared, so our engineering team feedback to us that the way how to handle asynchronous APIs is slightly more convenient. We're slightly more convenient for them through the Kubernetes client libraries than through Fabricate. However, probably the lessons that I would like to share here that we learn is if you have experienced developers in other language that do know API of Kubernetes client in other language, it's probably okay to use it. Nowadays on the market of development forces, you may find many developers that are familiar with building Go software for Kubernetes. That's why probably Go becomes more popular choice for building even Kubernetes operator. So what we are using custom resources for, there are, I would say, 4 things that I would like to give you here as a feedback. And the interaction with the custom resource definition and the whenever you build operator, there's a very important thing. Whenever you watch for updates, whenever you're building a watcher, so when you build this core functionality of the operator, there is some important aspects you need to be aware of. I will try to talk to you about status and events and the structure of the custom resource definition object, and also about our thoughts and our best practices with versioning custom resource definition. So initially, when we started to build operator, watcher code was very simple. It was like a library. We find out some library with some great samples. We used that as an initial watcher, and we started to use it for the operator. There are some few important problems that we face generally whenever we move to more production environments. We realize that whenever Kubernetes master control plane is busy, then we experience sometimes situation that events arrive out of order. So suddenly you get event, but you need to modify resource that hasn't been created yet, or modify some section inside your custom resource definition that hasn't been even created before. And of course, events are marked with a timestamp or with some ID that is technically probably a timestamp. So you can potentially find out that you receive event out of order. We are trying to do that. So we, in our watcher code, is checking the resource version that is really like a timestamp. And then when we are buffering the events for some time to react on them, and we realize that we receive an event out of order, then we swap them internally, and then we try to fix the ordering issue on the events. Sometimes when we find out that the event was missing, then we need to probably restart and recreate resources. Such situation may appear. We find it out regardless on many Kubernetes versions. We rather associate it with like a situation where Kubernetes is overloaded. So in an overloaded scenarios, control plane for us is able to send events for us out of order. And it is serious issues for building operator. So whenever you build operator, out of order watcher is probably a significant project, a problem you need to solve in your code. So you need to follow that. Our recommendation is to implement informer pattern. This pattern for building that kind of scenarios is well described in the literature. So you should look into that, and you should look into the articles about the informer pattern if you designed your own operator. Another thing is you need to be aware that your operator probably is able to store inside the custom resource some temporary information, and you sometimes need it for your implementation. So if you look into the custom resource, there are 3 sections in this object. It's metadata, spec, and status. So generally, spec is something that you should never touch, or at least we never touch in our operator, except of this REST endpoints that I was talking about, changing the life cycle. But status is a place where we are storing a lot of information about the current status or unexpected status of behavior. If you want to persist some information to protect you from crashing and be able to recover and continue after a restart, we are using a status section to store it. I think it's a good practice. Also, you can follow that in your situation. And another important thing is something that we started doing recently. We are doing right now. We are providing an ability to make our operator, I'd say, multi-version compatible. Multi-version in the meaning of multi-version of custom resource definition. As we evolve our project of operator, we added to the custom resource definition more and more information. So we needed to change the schemas and make a different versions in production. So particular version of operator work with a particular version of custom resource definition. Over time, we find out customers do expect to upgrade operator without upgrading custom resource definitions. So we right now enable operators for running and working with multiple custom resource definitions. So it is ability to version CRD and ability to work with multiple versions for backward compatibility. We believe is like a key feature that has been demanded from us by many of our enterprise customers that are following the journey. That feature enables you smoothly over time to upgrade operator and production of your customers without really stopping the applications, and we are fully recreating the entire environment as an upgrade process. There is an API that enables that. Generally, Kubernetes allows you to define like a webhooks that are invoked whenever someone changes a version of custom resource definition. So whenever the version is being changed of the CRD object, Kubernetes is able to call webhook on operator, and operator can react and can modify its own behavior or can modify the resources that are created based on the custom resource definition. This is to follow the recommendation or requirement that we had from customers, not to down the applications while you make your lifecycle operations of the operator easier. And the last thing that I want to talk is answer the initial question that I had in my agenda is, would we change or would we do the same if we needed to write it again from scratch, operator for our app server? And I need to tell you, I did that survey with few key architects in our dev teams, and they were saying, no, even after all these lessons, after all those journeys that we made with operator, changing the watcher, reacting and resolving problems of heavy loaded Kubernetes or versioning schemas, we would keep the same architecture for the project. The only thing that we probably would change is we would remove the REST endpoints, REST services that I have here into sidecar container. So we would probably create it like a separate container, separate software for just serving REST endpoints. It's mostly for the simplicity and clarity on the architecture, so to avoid any kind of mismatch of functionality. Right now, we believe it's not so purely designed. We are having a watcher on the custom resource. We have a watcher on resources that we created, but we also do serve some REST endpoints for some lifecycle management, like scale up, scale down, and so on. We would probably, in our architecture, move it somewhere else. I also need to share with you that if you provide enterprise software, if you build enterprise software for your customers and you want them adopt Kubernetes because you want to react on their demand, I think building operator is the best way to help them to achieve that. We make many discussions with our customers about adopting Kubernetes. And until we had a really Kubernetes operator in our portfolio, everybody was like very skeptic about moving such kind of complex platform like application server as with entire configuration into the Kubernetes. Once we have our operator, these discussions are still sometimes difficult, but definitely are smoother because we can show them how not only to move the product, not only move the configuration, but also design and run the lifecycle operations that they perfectly execute on the traditional VM environments suddenly and the Kubernetes. I think that's half an hour of my presentation. Let me check if there are any questions. If you have any questions, so no questions were posted, I received here information. So if you have any question, you may post them on the Q&A platform, and they are going to be copy pasted here to the chat so I can answer. If there is no question, then that's basically end of my presentation. Thank you very much for participation today. I hope you enjoyed the best practices about operator, and I hope you'd be successful with building operator for your resources for your production customers. Thanks again.